able to see my whiteboard? Just confirm.
Yes, sir.
Yes,
Yes.
this is a second lecture on work, energy, and power. No, the second lecture on work, energy, and power. So before getting into work means, I told you right. Work means what I told you. It is simple. That is force into displacement. I told you no, and this force should be along the direction of displacement. No, whatever force is there, it should be along displacement. No, yes. Clear, dear children?
Yes, sir.
This work has to be along the displacement, I told you. Now, after that, we started about energy. After doing some numericals on this, we started about energy. And in energy, we discussed so many kinds of energies, but we are going to study about something called mechanical energy in our ninth standard. In mechanical energy, how many are there? There are two types of energy. One is like potential energy, another is like kinetic energy, right? We're looking at the potential energy. What do you mean by potential energy? Potential energy means it is due to position. Yes, it is due to position or configuration, right?
Yes, sir.
Yes or no? It is due to position or configuration. Everybody knows that. Now, before going for that potential energy formula and all, let us try to understand a few words. One is like mass. Mass is like m. Another is like weight. Mass and weight. Let us try to understand them. Have you heard these terms, mass and weight?
Yes, sir.
Yes, sir.
Yeah. Mass means it is very simple. What is that? Amount of substance available. Mass means what? Amount of substance available. Whatever substance is available, no. So that is only known as mass. Clear, dear children? Whatever amount of substance is available. For example, I have got one body here. Okay, one body is there. So inside that body, there will be so many molecules, no? So many
Yes, sir.
molecules are there, one molecule, two molecule, three. I mean, whatever this amount of substance, how much it is there. So that is known as mass. What kind of, how much amount is there? That is only mass. If you go for its SI unit of mass. If you go for just, I mean, unit of mass means how many units are there? There are so many units of mass. Now, already I think I have discussed it in the previous classes also. Unit of mass, what are the units of masses? Kg, then gram, then quintal. Yes, then there is something called ton, and there is something called pound. Yes or no? But what is the SI unit? SI unit is
KG.
going to be kg. Yeah, SI unit of mass is kg. Is that clear, dear children? Now,
Yes, sir.
Vaishali is asking
Yes, sir.
why mass becomes infinite at the speed of light. Again, Vaishali, you need theory of relativity for that. Again, we have to leave ninth standard and we have to go for our degree studies. If I keep on answering that, I'll answer them, but not at this moment. Yes, Vaishali.
Yes, sir.
Yeah, I know mass becomes infinite. There are so many formulae for that, but this is not the platform for that. There will be different platform for that. Okay.
Yes, sir.
And you will be asking me, where is that platform? That platform is like YouTube. You can understand it by YouTube, and you can understand it by from my side only on holiday. On a holiday, if you are interested on those topics, I will conduct half an hour class for that, and I will confirm that. Okay.
Yes, sir. Thank you, sir.
Yeah. Okay, fine. So this is like regarding mass. Now, when we say weight, no, weight means, dear children, weight means the symbol is like W. Weight is nothing but force, dear children. Whatever force is there, no, that is called weight. Look at this. I mean, force means, now this is the body, right? This body is having mass m. Now, will this body be pulled below like this? Always it is pulled below, no?
Yes, sir.
Yes or no? Whenever you are keeping it on any surface or if it is hanging on the tree, wherever it is, it will be pulled with some acceleration, right? So that acceleration is called acceleration due to gravity, right? Yeah.
Yes, sir.
Yes, sir.
So now force equal to, what is the formula? Force is equal to some formula is there, that is M into A. And M is there as usual. Instead of A, what I'm going to write? I'm going to write G right here. I'm going to write G here, then it becomes W. So the formula for weight is like mg. Always, if any body is having mass m means it is having weight which is equal to mg. Clear, dear children?
Yes, sir.
Yes, sir.
Yes. Now, if somebody is asking you what is the unit of weight, what is the SI unit of weight? SI unit of weight is like m means kg, g means meter per second square, kg meter per second square. This is only known as Newton. Clear?
Yes, sir.
I
Yes, sir.
explained this. What is 1 Newton and all? I have explained in the last classes. Your recorded videos are also there. You can see them in laws of motion. Clear, dear children?
Yes, sir.
Yes. Unit of weight is like Newton. The unit of weight is Newton. Why if somebody is saying weight, my weight is 10 kg, it is wrong. In physics, if I say my weight is 10 kg, no, my weight is 10 kg, it is a wrong statement. No, I cannot say like that. Okay. I can say my mass is 10 kg. My mass is 10 kg. We can say that. Clear, dear children? Yeah.
Yes, sir.
Yes, sir.
Now, if any body is having, for example, I'm giving, if any body is having mass of 10 kg, if it is having mass of 10 kg, what will be its weight? Weight is equal to mg, mass means 10, and g means, here you can take minus 10, but weight is usually put up in positive only. So downward, no, so no problem. So that is like 10 into 10, 100. So weight will be 100 Newton. Clear?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Now look at this. Yes, look at this. Wherever you go, mass do not change. Mass of a body on Earth is equal to mass of the same body on Moon. Mass of a body, same body, mass of a body on Moon. Both are same because amount of substance is never going to change until and unless you take out something from this. Clear? But weight of a body on Earth, weight of a body on Earth is not equal to weight of a body on Moon. Clear? Is it clear? Yeah. I told
Yes,
this,
sir.
I guess. Already I have explained this. Why I'm explaining these things is the thing is like, for example, here is one body. For example, here it is the Earth surface. Surface of Earth is there. And there is one body, I mean, there is one wooden block like this with mass m. Now, to lift this, you are supposed to do the work or not? Tell me. If I want to take it
Yes,
above
sir.
to this position, should I do work or not? Why should I do work? Tell me. I should do work because this body is getting pulled downward with force mg, right?
Yes, sir.
Yes or no? It is getting pulled with force mg. Now, if I want to lift it, now for example, mg is like, for example, 100 Newton. Now, if I apply a force of 80 Newton, will it come above?
No, sir.
No, right? It won't come, no? So I should be applying at least force. So this force, whatever I'm applying, no, at least this force should be mg. At least it should be mg. Clear?
Yes, Yes, sir. sir.
Yes, sir.
It can be more than that, but minimum is like mg. Clear, dear children? Minimum it has to be mg. Clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now this body, you are applying on this body, you are applying a force. This force you are applying, how much force you are applying? That force equal to mg. And this body, from this place to this place, you have taken it for some displacement. Okay, some displacement you have taken it. Let me call that displacement as h. Clear? Height, no, some height you have taken it. Clear, dear children?
Yes, sir.
Now, what is the formula for work done? Work done is equal to force into displacement, no? Fs, no?
Yes, sir.
Yes, sir.
Now, what is the formula for force you got? mg you got there. Look at this, force equal to mg. And S means h, no? Yes or no?
Yes, sir.
Yes, sir.
Yes. Now, whatever work you are doing here, that work done is converted to energy or not? That work done is converted to energy. Work done is converted to energy. That too, work done is converted to Potential energy, it is getting converted. Yes, I told you yesterday. For example, here is water and here is the syntax. Now you are having a motor here. Now this motor, what it does? It does work, no? So work done is converted into energy here, no? Water is having more energy at more height, no? Yes or no?
Yes.
Yes,
Yes, sir.
So in physics, work and energy are same things. Whatever work you are doing now, that will be converted into energy. That too, especially potential energy. That's why instead of that work, I am going to write it as potential energy, and potential energy equal to mgh. Can I write it like this, dear children? So whatever
Yes,
work
sir.
done I had here, no. So that's what I'm going to write it as potential energy. Is it okay?
yes, sir.
Yes. One more
Yes, sir.
symbol for potential energy we use, that is called U. Capital U. Capital U is used for potential energy. We can use any symbol, but U is used usually in the books. That's why U is equal to mgh. Clear?
Yes, sir.
Yes, sir.
I hope everybody got it. Yeah.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Fine. So you got a formula for potential energy, that is like mgh. Potential energy means mgh. Now let me give you one simple example. For example, this is the Earth surface. This is the Earth surface, and here there is a tower. Okay, there is a tower of height. Let me take the height of the tower is like 20 meter. If it is 20 meter, now there is a boy standing here. Now this boy is having energy or not? Now if he jumps, will he come down without doing any work? There is no need for him to do any work. He will come down. No, that means he must be having energy. No.
Yes, sir.
Yes or no?
Yes, sir.
Due to that position. Now, to climb that, he has to do the work or not? To climb this height 20 meter, whatever this 20-meter high building is there now, to climb that, he is supposed to do the work or not?
Yes, sir.
Yes,
sir.
Yes or no? So that work itself is converted as what? Potential energy, no? Yeah, so
Yes, sir.
okay. Now what they're asking, this boy is having a mass of, let me take, he's a little bit heavy boy, 50 kg. Okay. Now they're asking, what is the potential energy of that boy? Potential energy of that boy equal to question mark. Okay. Here is the boy. Okay. Now if they're asking like this, what is the formula for this mgh? No? Yeah.
yes, yes, sir.
Correct, no?
Yes, sir.
M means 50 kg and G means, don't take it as minus 10 right now. That minus 10 thing is motion is over now. This is a different issue. And height is like 20 meter. So if you do all this, so 50 into 10, 5 into 2 is like 10, then other 3 zeros. So it becomes 10,000 joule, no? Yeah?
Yes, sir. Yes, sir.
Are you understanding my point, what I'm trying to say? Yeah? So
Yes.
he is having potential energy of 10,000 joule. Okay. Now how much work he must have done to climb this? He must have done 10,000 joule of work, no?
Yes, sir.
Yes or no?
Yes,
So
sir.
he must have, yes, to go for more height, if he is supposed to go for more height, for example, 30 meter. Now if he wants to go here, okay, this boy, he is supposed to do more work or less work?
More work. More
Then
work.
more work means he will be having more energy here, no?
Yes, sir.
Yes, sir.
So that's why work done and energy, they are like interrelated. They are like the same things, dear children. So I hope this is clear. Okay.
Yes, sir. Yes, sir.
Yeah. Okay. Shall I go to next thing now?
Yes,
Yes,
sir.
sir.
Okay. Now do this question, all of you. Let's see will it happen or not. Now one more thing before going to the question. Now this is the Earth surface, for example. Okay, this is the Earth surface. Now here is one body of mass m. Okay, here is mass, gravitational field strength, vertical height. Mass, gravitational field. Gravitational field is different thing, Moksha. We don't call it as gravitational field. We call it as acceleration due to gravity. Please try to understand what I'm trying to say. Yeah. Okay.
Okay,
All
sir.
right. So now, yeah, here also one mass is a gravitation field is a different thing. Now this mass, same mass, both are same to same. Everything is same. They are like equal, each and everything. Now I take this body just in a straight way to this height. I take like this straight. Okay. Now I take this body like this. I just turn and twist and I take this body to this height. Okay. Now, what will be the potential energy of both of this? Now, this is having potential energy U1. This is having potential energy U2. Now, tell me, this path we have taken, no? Now, they are asking potential energy of first body divided by potential energy of second body. What is the ratio of potential energy of both the bodies? Tell me. This is also height h only. Here also height h only they have got. So both are same, no? There also potential energy is like mgh, and here also potential energy is mgh, no? So it do not depend upon this path and all. Wherever this path you are taking, no, it do not depend on that. Potential energy do not depend upon the path. Potential energy depends upon only mass. One thing is like mass, another is acceleration due to gravity, it is same, and another is like h, how much height you have got. Clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, for example, there is a, there is a temple here. Okay. For this temple, both of you start from same point. Person A and person B, they start from, same point. Now, this person goes like this, and this person goes like this. Now, who has done more work? Tell me. No one has done more work now. No, 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 no. Both have reached temple only, no?
Yes, sir. Displacement
Yes,
is
sir.
same
Yes, sir.
only.
Yes, displacement is same. No, both are having same displacement. The displacement is like height this one, no? Initial point to final point. Yes?
Yes, sir.
Yes.
So that's why what I'm trying to tell, potential energy do not depend upon the path taken. Yes? Potential energy do not, now this is like mgh cancel means 1:1 it is. Okay? So what I'm saying is potential energy do not depend on, do not
Path.
depend on path taken. Whatever path we are taking, it is not depending on that. It is depending on the mass, acceleration due to gravity, and height. Clear, dear children?
Yes,
Yes,
sir.
sir.
Please note it down quickly. Let me have some water. Shall I go for next question?
Yes, sir.
Yeah.
Yes, sir.
Is the white screen visible?
Yes, sir.
Visible.
A boy of mass 25 kg climbs a building, climbs a building of height 10 meter. Find work done by him. Find work done by him. Everywhere you have to take the value of g as 10 only. Try to understand 25 meters. Find the work done by him. Quick. Moksha, gravitation, yes, 2500 joule, correct. What is the mass of the
Yes.
boy? 25 kg. Moksha, gravitational field is different thing. I'll explain you later. Okay. Height is 10 meter. Height is 10 meter. Okay. Now work done they're asking. Work done means you understand, no? This is the ground and here is the building 25-meter high. Okay. Now the boy wants to climb here. Boy started from this point. Now the boy is here. He started and he did work. And whatever work he did, that is converted into potential energy, no?
Yes, sir.
Yes. So you find out potential energy only. Potential energy equal to, you say, mghl. Later words, that potential energy is only work. So that is like, this is only equal to work here. Okay. So that is 25 into 10 into 10. That becomes 2500 joule of work he has done. Yes. He has done this much of work. Clear, dear children? Yeah. Now, do you have any idea like 1 kilojoule means how many joules? 1 kilojoule is like 1000 joule, no?
Yes, sir.
Yes,
Yeah, like that. If I say 2.5 kilojoule, how many joules it is? It is 2,500 joule, no?
Yes, sir.
Yeah.
Yes, sir.
So like that, kilojoule to joule means into 1000, and joule to kilojoule means instead of this 2,500 joule, can I write it as 2.5 kilojoule?
Yes, sir.
Yes or no, sir? Acceleration due to gravity. No, I mean, Krishna Shiro. Neela, I mean, we are taking for everything, we are taking it as 10, okay? And just to keep our calculation simple, okay? We are taking G equal to 10, Neela. Okay? Usually in most of your exams, it is taken as 10. And you can take 9.8 also, but try to take it as 10. Yeah, so that our things become very simple. Yeah? Neela, I hope you
Yes.
understood what I'm saying.
Yes,
Yeah.
sir.
So this is approximately equal to 10. Okay, fine. Shall I go to next problem?
Yes, sir. Yes.
Yes, sir. Yes.
Okay, all right. Now, okay, fine. So is this study material uploaded?
Yes, sir.
Yes, sir.
Yes,
Uploaded,
sir.
sir.
Okay, fine. Thank you. Now, is the whiteboard visible? Confirm.
Yes, sir.
Yes, sir.
Yes, sir.
Visible.
Yes, sir. Visible.
Okay. Now, in an amphitheater means you guys know. In an amphitheater ಅಂದ್ರೆ ಈ ರೀತಿಯಾಗಿ ಹಿಂಗ್ ಕುತ್ಕೊಂಡಿರ್ತಾರಲ್ಲ, ಹಿಂಗ ಅಲ್ಲಿ ರನ್ ಸ್ಟೇಡಿಯಂ ಒಳಗಡೆ ಹಿಂಗ ಅದ ನೋಡಿ, ಇರಾಕ್ ಅದ ನೋಡ್ರಿ,
Yes,
ಮ್ಯಾಲ
sir.
ಇರಾಕ್.
Yes.
ಆ
Yes,
ರೀತಿಯಾಗಿ
sir.
ನಾಲ್ಕು ಸೈಡ್ ಹಿಂಗಿತ್ತಂದ್ರ ಹಂಗೆಲ್ಲ ಕೂತಿರ್ತಾರ ಮಂದಿ, ನಡು ಶೋ ಇರ್ತದ, ಆಂಪಿಥಿಯೇಟರ್ ಅಂತ ಕರೀತಾರೆ. ಇನ್ ಅನ್ ಆಂಪಿಥಿಯೇಟರ್ ದೇರ್ ಆರ್ 50 steps. There are 50 steps, each of height 4 centimeter. Each of height 4 centimeter. Find the work done by a man of 100 kg to climb to the top. 100 kg ಅಂದ್ರೆ ಪಾಪಂ ಇರು, ಅದಕ್ಕೆ ನಾಕೈತಿ ಏನಿದ್ರು ಇರಾಕ್ ಬರ್ತೈತೆ ಇದನ್ನ. Find the work done by a man of 100 kg to climb to the top. Climb to the top. Yeah? Yes. I'll give you the options. 1 kilojoule, 1.5 kilojoule, 2 kilojoule, 2.5 kilojoule. ಏನ್ರಿ ಸರ್ ಇದು 50 ಸ್ಟೆಪ್ ದೊಡ್ಡ ತ್ರಾಸ ಆತ್ಲ
Sir,
ನಮ್ಗೆ.
C.
C, yes, correct. C is correct answer. Good, Vaishali, nice, awesome.
Yes.
C is right answer. Have you solved it or not?
Salt, sir.
You have to solve it neatly, okay? C is right answer, okay. 2 kilojoule, not kg, 2 kilojoule. Okay, fine. So it's very simple, no, dear children? How to do it? Tell me. So there are 50 steps in an amphitheater. There are 50 steps, each of 4 centimeters. Steps are ಹೆಂಗಿರ್ತಾವ ಇಲ್ಲಿ ಹಿಂಗೊಂದು ಹಿಂಗಿರ್ತಾವಲ್ಲ steps.
Yes, sir.
Yes.
Yes, sir.
ಹಿಂಗ 50 ಸ್ಟೆಪ್ ಅದಾವ. ಒಂದೊಂದ್ ಸ್ಟೆಪ್ 4 ಸೆಂಟಿಮೀಟರ್ ಹೈಟ್ ಅದಾವ. ಹಿಂಗ ಇದೊಂದ್ 4 ಸೆಂಟಿಮೀಟರ್, ಇದೊಂದ್ 4 ಸೆಂಟಿಮೀಟರ್, ಇದೊಂದ್ 4 ಸೆಂಟಿಮೀಟರ್, ಹಿಂಗ್ 4 ಸೆಂಟಿಮೀಟರ್ ಅದಾವ. ಅಂದ್ರ ಟೋಟಲ್ ಹೈಟ್ ಎಷ್ಟ್ ಆಕೈತಿ ಹೇಳಿ ನೋಡೋಣ. ಟೋಟಲ್ ಹೈಟ್ 50 into 4 ಸೆಂಟಿಮೀಟರ್ ಆಕೈತಿಲ್ಲ.
Yes, sir.
50 into 4 ಅಂದ್ರೆ ಏನಾಗ್ತದೆ? 200 ಸೆಂಟಿಮೀಟರ್ ಆಗ್ತದೆ ಇಲ್ಲ. ನನಗೆ ಸೆಂಟಿಮೀಟರ್ ಒಳಗೆ ಬೇಕಾಗಿಲ್ಲ, ಮೀಟರ್ ಬೇಕು. 200 ಸೆಂಟಿಮೀಟರ್ ಎಷ್ಟು ಮೀಟರ್? 2 ಮೀಟರ್ ಹೌದಿಲ್ಲ?
2.
ಹಾ?
Yes, sir. Yes,
ಆಗ್ತದಾಗಂಗಿಲ್ಲ ಹೈಟ್. ಎಸ್, ಹೈಟ್
Yes,
ಇಸ್
sir.
ಈಕ್ವಲ್ ಟು 2 ಮೀಟರ್ ಆಗ್ತದ. ಓಕೆ,
2
ಫೈಂಡ್
meter.
ಆಮೇಲೆ 2 ಮೀಟರ್. ಆಮೇಲೆ ಮಾಸ್ ಆಫ್ ದ ಮ್ಯಾನ್ ಎಷ್ಟದ? 100 kg ಇಲ್ಲ?
Yes, sir.
Yes, sir.
ಸೊ ಅವ ಮ್ಯಾಲ್ ಹತ್ತಿ ಹೋಗ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಾಗೈತಿ, ವರ್ಕ್ ಮಾಡ್ಬೇಕಾಗೈತಿ. ಆ ವರ್ಕ್ ಮಾಡದ ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಆಗೈತಿ, ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಆಗೈತಿ. ನಾವು ಟೋಟಲ್
Potential.
ಲೇಟ್ ಹೈಟ್ ಹೋಗಿರ್ತಾನೆ,
Yes, sir.
ಎರಡು ಮೀಟರ್ ಹೋಗಿರ್ತಾನಿಲ್ಲ. ಓಕೆ, ಅಷ್ಟೆಲ್ಲ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೋಬೇಕದ್ನೆಲ್ಲ ನೀವು. ಓಕೆ, ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗ್ತದ, ಎಂ ಜಿ ಎಚ್. ಆ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ವರ್ಕ್ ಆಗೈತೆ ಅಷ್ಟೇ, ವರ್ಕ್ ನ. ಸೊ 100 kg ಅಲ್ಲ, ವರ್ಕ್ ಆಕೈತಿ ಅಂದ್ರೆ ಏನು, ವರ್ಕ್ ಮಾಡಿದ್ದು ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಎರಡು ಒಂದೇ ಇವ. ಹೌದಾ, ನೀವು ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಅಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಬರ್ತದ. ಓಕೆ, 100 into 10 into h is like 20. ಹೌದಲ್ಲ, 2000 ಜೌಲ, 2000 ಜೌಲ 2 ಕಿಲೋ ಜೌಲ್. ಅದಕ್ಕೆ 2 ಕಿಲೋ ಜೌಲ ವರ್ಕ್ ಮಾಡ್ತಾನ ನಾವು ಹತ್ಬೇಕಂದ್ರೆ. ಗೊತ್ತಾಯ್ತು?
Yes, sir.
Sir, height is
ಮುಂದಕ್ಕೆ
2 meter.
ಸಾರಿ 2 ಮೀಟರ್, 2000. ರಿಯಲಿ ಸಾರಿ, 2 ಕಿಲೋ. ಕರೆಕ್ಟಾ? ಫೀಲ್ ಬಂತಿದ್ದು ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಇದು ಹೆಂಗಂತ ಹೇಳಿ.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Next, kinetic energy. Next, we are going for kinetic energy. What do you mean by kinetic energy? Kinetic energy
The
means
result of
energy of
potential.
energy. No, not a result of potential energy. Energy of a body. Energy of a body due to its motion. Due to its motion, ಅದ್ರ ಎನರ್ಜಿ, ಅದ್ರದ್ದು ಮೋಷನ್ ಇಂದ ಬರುವಂತ ಎನರ್ಜಿಗೆ ಏನಂತ ಕರೀತಾರೆ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಂತ ಕರೀತಾರೆ. ಹೌದ್ರಿ? ಈ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದೇರ್ ಇಸ್ ಎ ಬಾಡಿ ಆಫ್ ಮಾಸ್ ಎಂ, ಒಂದ್ ಬಾಡಿ ಮಾಸ್ ಎಂ ಅದ ತಿಳ್ಕೊರಿ. ಅದು ವಿ ವೆಲಾಸಿಟಿಲಿ ಹೊಂಟದ ಅಥವಾ ವಿ ಸ್ಪೀಡ್ಲಿ ಹೊಂಟದ ಅಂದ್ರೆ ಇದ್ರಂತಲೇ ಇರುವಂತ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎಷ್ಟದ ಗೊತ್ತಂದ್ರೆ, ಇದ್ರ ಡೆರಿವೇಶನ್ ಐತ್ರಿ 11th ಕ್ಲಾಸ್ನಾಗ. ಈ ಡೆರಿವೇಶನ್ ಇಲ್ಲ, ಬೇಕಾಗೂ ಇಲ್ಲ ನಿಮ್ಗೆ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎಷ್ಟು ಈಕ್ವಲ್ ಟು ಎಷ್ಟಾಗ್ತದ್ರಿ, ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್. ಎಷ್ಟಾಗ್ತದೆ ಹೇಳ್ರಿ, ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್. ನೆನ್ಪಿಟ್ಕೋತೀರಿ ಇದನ್ನ? ಹೆಂಗ್ ಗೊತ್ತು ಏನ್ ಗೊತ್ತು ಬೇಡ,
Yes, sir.
ಬೇಕಾದ್ರೆ ನೋಡೋಣ ಆಮೇಲೆ. ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್ ನೆನ್ಪಿಟ್ಕೋರಿ, ಇದನ್ನ ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಗೊತ್ತಾಯ್ತು?
Yes, sir.
Okay.
Yes, sir.
So kinetic energy means energy of a body due to its motion. ಅದು ಮೋಷನ್ ಇಂದ ಬರುವಂತದ್ದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಂತ ಕರೀತಾರೋ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಈಕ್ವಲ್ ಟು ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್. ಕ್ಲಿಯರ್?
Yes,
Yes, sir.
Shall I go to next question now?
Yes, sir.
Yes,
All
sir.
right, let me go to a question and let me solve that. The question is like this. Okay. Energy which body possesses by virtue of being in motion. Okay, so by virtue of motion, all these fancy words are used. I'm using simple words. I'm a simple man, Moksha. Yeah.
Yes.
So what I'm using, I'm a simple man, that's why I use energy of a body. Energy of a body due to its motion, by virtue of its motion. Both are same things. Yeah. All right, thank you. I mean, I can write all those words by virtue of its motion and all, but I don't want to write all of it. Moksha, is that clear? Yeah. Okay, all right. Write down this. A body of mass 10 kg started from rest and gains an acceleration of 10 meter per second square in 2 seconds. Find kinetic energy of body after 2 seconds. Okay, please do this. Do this question all up. Tell me the answer also after doing this. Yes.
500.
Good. Maybe. What is the mass of the body? 10 kg. 500 what? 500 something has to be there. No, mass is 10 kg. Started from rest means initial velocity is 0, right? And gains an acceleration of 10 meter per second square, no? In how many seconds? In 2 seconds. Now they are asking kinetic energy after 2 seconds. So after 2 seconds, what is the velocity of the body? That's what we need to calculate now. So what will be the velocity of the body? We know formula V equal to U plus AT, no? Yes or no?
Yes, sir.
Okay. So then U is like 0. The value of U is like 0. Some people are commenting the answer. Okay, let's see. So U is like 0 plus A is 10 into T is 2. So 0 plus 20 is like 20, no? 20 meter per second, no? After 2 seconds, what will be its velocity? 20 meter per second, no? Yes or no?
Yes, sir.
Yeah. Then what will be its kinetic energy? The kinetic energy will be half mv square, no? So half mv square is like half into m is 10 kg and v square is 20 square, no? Then 2 ones are 2 fives are. Then it becomes a 5 into 20 square means 400, no? So 400 is like 2000 joule. So 2000 joule means 2 kilojoule you can write. Yes, what is the kinetic energy after 2 seconds? 2000 joule. I think Sahana commented right answer. So initially, 2 kilojoule. Vaishali commented later. I'm reading the names from the bottom, okay? Then Supriya Patil, Sanjana. And Rishikesh 250 joule. No, 250 joule is not correct. 500 joule is not correct. 500 joule is not correct. 2 kilojoule. 2 kilojoule is correct. Yes, clear?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Kinetic energy means half mv square. That's what you need to remember. And on that only you have to build your concept. Clear, dear children?
Yes, sir.
Yes, sir. Yes, sir.
Shall I go to next thing?
Yes, sir.
Okay, fine. Now I can go for power also. For power there is a time, but you try to understand this law of conservation of energy. Everybody heard of this term?
Yes, sir.
Law of
Yes, sir.
conservation of energy. What do you mean by conservation?
Remaining same.
I told you, no? Conservation means remaining same. There is some law for conservation of energy. Actually, everybody says law of conservation of energy, only one statement, but there are 2-3 statements for this. Law of conservation of energy, first statement is energy can neither be created nor be destroyed. What is the first statement? Energy can neither be created nor be destroyed. Correct? Everybody knows it or not?
Yes, sir.
Okay, we cannot create. Okay, energy creation is not possible. That is not our task. We cannot destroy also. Energy creation and destruction is not in our hand. Now, second statement is like energy can be transferred from one form to another form. What is the second statement? Energy can be transferred or transformed also is correct. Transferred from energy can be transferred from one form to another form. One form to another form. I will explain you how it comes, how it is converted. One form to another form. Second statement, is it clear?
Yes, sir.
Yes, sir.
Yeah. I will explain all of it. Now, third statement is like in the process of transfer of energy, in the process of transfer of energy, in the process of transfer of energy from one form to another form, from one form to another form, one form to another form, work is done. Work is done. Have you heard this before, this third statement, dear children? Starting to you must have heard, but third one have you heard? I'm asking.
No, sir.
No. In
No,
the
sir.
process of, okay, look at this beautiful statement, how it is. In the, this is not there in 9th standard also, because that's why you have to learn from the people, those who are in both the sectors. Okay. In the process of transfer of energy from one form to another form, work is done. So what does it mean? Look at this. You take example of anything, any system in the world. For example, if you take the example of motorbike, okay, bike. I mean, you have one bike here. In that bike, what you put? Tell me.
Petrol.
Fuel, no?
Fuel.
Fuel you put. So fuel means what kind of energy it is?
Chemical.
Chemical.
Chemical energy, right? Now, once you start the bike by using that fuel, will the sound come?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Will it get heated?
Yes, sir.
No,
Yes,
bike
sir.
will get
Yes, sir.
heated or not? Silencer pipe and all.
Yes, sir.
Silencer.
Will it move? Will it move?
Yes, sir.
Move, sir.
Yes, sir. Yes,
It
sir.
moves.
Yes.
Now, sound is also energy, heat is also energy, movement is also, I mean, this is like, movement means what kind of energy it is? A movement means kinetic energy, no?
Yes, sir.
Yes, sir.
Yes, sir.
Mechanical
Kinetic energy
energy.
means it is a, kinetic energy means it is a type of mechanical energy, no?
Yes,
sir.
sir.
Now, during all this process of conversion of this chemical energy to all this sound energy, heat energy, and this momentum or this mechanical energy, what is done? Bike is moved. Some work is done by the bike or not?
Yes, sir.
Are you getting my point? In this process, work is done, yes or no? Because there is a transfer of energy, means work has to be done, no? Are you getting my point? Why will I transfer my energy to you? Because that is some kind of work, no? I will give my money to you, no? Why I am giving my money to you? Because I mean, you are doing some work for me or not?
Yes,
Yes or
sir.
no?
Yes.
Yes. That gas is nothing but heat only, moksha. Whatever gas comes, no, that is like heat only. No, you can call it as smoke energy also. Sound also comes, heat also comes, that is also there. And you can say some smoke also. Yes or no? Smoke comes in heat only, moksha. Yeah. I mean, everything, heat, everything will get into heat energy. Last, no, at last, everything will get into heat energy. This sound energy also will get into heat energy. This is the ultimate energy, heat. Okay, leave that. Now, if you take any dam, have you seen any dams? Almaty Dam
Yes,
and
sir.
all?
Saucer.
Okay.
Yes, yes, sir.
Yeah. In this dam, it is at more height, no? Like this, it is at more height now. Water is at more height. Now, here, what kind of energy this water is having? Tell me. Potential energy, no?
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Now this water is channelized through these gates, through these pipes and all. Okay. Now here it is having potential energy, and now it is converted into kinetic energy, no, into the pipe.
Kinetic energy.
Yes,
Yes, sir.
sir.
Yes, sir.
Now there are some turbines here. Now this turbine rotates. Now this is the turbine here, and this turbine rotates. This turbine is rotating means again it is kinetic energy, and by using turbine we have generator. What is produced? Electricity is produced, no?
Yes, sir.
Yes, sir.
Yes,
sir.
sir.
So electrical energy is produced. Now look at this. Now this is like a potential energy to kinetic energy to electrical energy. In this whole process, what is done?
Work.
Transfer of.
Work is, yes.
Work.
In this transfer of energy, whatever energy is transferred, no, in that process, work means this rotation. No, work means what? This rotation of this. This is the work or not?
Yes, sir.
Yes, sir.
Are you getting my point? Whenever there is a transfer of energy, dear children, work is a must thing. I mean, transfer of energy is happening means there must be some work. Clear?
Yes, sir. Yes, sir.
Yes, sir.
Now, Neela is asking which is more powerful energy. How can I say which is more powerful energy? If you go for that more powerful energy and more efficient energy, that is called calorific value, that is nuclear energy. Nuclear energy is having a lots and lots of potential. Yes?
Yes, sir.
Yes, nuclear energy is having lots and lots of potential, and that is having disadvantages also. That is called calorific value. We'll come to that later stage. Okay, in 10th standard, we'll come to that in sources of energy. Okay. Yes, I hope it is clear. All right, dear children. Sir, why gravitation is called the weakest energy? Again, that's a different thing. Again, that you have to enter for 11th class because that is the weakest force. Gravitation force can exist between me and you, Vaishali? Can the gravitation force is there between me
No,
and you?
sir.
No,
No,
it
sir.
is there. Between me and you, it is there, but it is very, very,
very
very,
less
very, very,
amount.
very, 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 very weak. I mean, very small it is. Yeah,
Negligible amounts.
negligible. So that's why it is called the weakest force. Okay, yeah. Okay, fine. So is it okay now? Whatever I have told?
Yes.
Yes, sir.
You should
Yes,
not
sir.
look at the things like which is the weakest and which is the strongest. You should not see at the things like that. You have to see at the things whenever something is useful, you have to, I mean, use for that. Is the study material uploaded?
Uploaded, sir.
Yes, sir.
Yeah.
Sir.
I hope the law of conservation of energy is very, very clear to you, all of you. Yeah.
Your screen is not
Yes,
visible,
sir.
sir.
I know I closed the screen. I closed it because 12 pages are over, no? So that's why. Yeah. All right, dear children. I hope you guys are enjoying all these concepts. I feel. Are you guys enjoying all these concepts?
Enjoying,
Yes,
Yes,
sir.
sir. Yes, sir.
Yeah.
And interesting
Because
also, sir.
Enjoying.
very interesting, and when the concept of this thing comes, no power comes, no, your mind will be blown off. This is how electrical devices work. Electrical devices are there in 10th standard, but I will teach them in 9th standard only. Don't worry about that. Okay.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, do you want many students to learn like this, or you yourself want to learn these concepts?
We want
Many
many
students,
students to
sir.
learn, sir.
Many students, no. So you should be inviting many of your friends. Usually, what I'm telling, dear children, I mean, why we are into 9th and 10th section, the only and only reason why we are into 11th, 9th and 10th, we are in 11th and 12th. The 9th and 10th fundamentals, nobody is building in Mudur. Everybody is like, I mean, just doing normal thing, just roaming around, just learning one or the other thing, and not giving too many assignments, not too many high level questions, just normal question, and they are completing their 9th standard and 10th standard. We don't want to do that. We want to get into depth of the subject. Clear?
Yes,
Yes,
sir.
sir.
Yes,
Now, right now, we have some Samuel students here. We have some students from Sai Niketan also. We have some students from, I mean, from Lord Palace also. Some from Sai Niketan, some from Sangamnath also. They are there. You can look. You can have a look when you go back to your school. This is not ನಾನೇನೋ ಗರ್ವದಿಂದ ಹೇಳ್ತಾ ಇಲ್ಲ, ನಾನೇ ಹೇಳ್ತೀನಿ ಅಂತ ಹೇಳಿ. ನೀವು ಹೋಗಿ ನೋಡ್ಬೋದು, ನಿಮ್ ಟೀಚರ್ ಈ ಟಾಪಿಕ್ ಅನ್ನ ಹೇಳ್ತಾ ಇರ್ತಾರಲ್ಲ 9th ಅಲ್ಲಿ ಇರುವಾಗ, ಅವಾಗ ಅಲ್ಲಿದು ಇಲ್ಲಿದು ಅಬ್ಸರ್ವ್ ಮಾಡಿ, you will get that complete difference of topic of Kalparuksha classes. These are like very depth concepts and very clear concepts these are. Yes?
Sir, they will not tell properly
sir.
which is in textbook only, sir.
I know. That's why Kalparuksha classes. Yes? And many people are thinking like, sir, school is also there, tuition is also there. Which one we should be doing that? So what I prefer you is that tuition, whatever coaching class we have, this is like in-depth analysis. So that's why you should be relying on coaching classes for your physics and mathematics concepts and chemistry and biology concepts. PCMB, you should be relying on us. Clear, dear children?
Yes, sir.
Yes, sir.
Yes,
yes,
sir.
sir.
Yes, rely on us and we'll give you good content. Okay, along with the school, I am not blaming any school. I'm just telling the reality. I'm not blaming any teacher also. I'm just telling you the reality, what kind of situation they go through, because lots of work there, less salaries. I mean, they have lots of situations there. So that's why we cannot blame them also. Okay, it is our responsibility. Being a students, it is your responsibility to learn the concepts in one or the other place. And Kalparuksha classes is the best place to learn them.
Yes, sir.
Okay, fine, dear children. Today I will see you at 2 o'clock.
Yes, sir.
2 o'clock I will be seeing you with mathematics class, with all that median and all. 2 o'clock I'll be seeing you. Okay. And Vaishali is asking, what is the basic meaning of thermodynamics? Thermo means heat. Vaishali, thermo means what?
Yes, sir. Heat.
Thermo means heat. Okay. The meaning of thermo is like heat. Okay. Then dynamics means momentum, dynamics. Yeah. Dynamics means
Yes,
what?
sir.
Moment. So moment of heat, motion of heat is studied in thermodynamics. How the heat will be going, where the heat will go, tell me. Now, for example, here 100 degrees Celsius is there and here 20 degrees Celsius is there. So where the heat will move? Heat will go like this, no?
Yes, sir.
Yes,
From
sir.
high pressure to low pressure.
So heat, high temperature, no pressure, high temperature to low temperature.
Sir.
This is there in level. Yes.
Sir, one experiment is there, sir. In that, one big balloon they will take, sir. One small balloon they will take, sir. But
Okay.
when the both balloons are filled with same amount of air, sir, the small balloon is going to have more pressure due to its elasticity. So when they
Hmm.
let the air to release, sir, from a small balloon, the air will pass, sir, to big
Hmm.
balloons.
Why
So
that is high pressure to low pressure, that thing is there. Again you are getting into high pressure and low pressure, some other concepts. I mean, what I prefer, Vaishali, what you are asking is very good. I mean, all those
yes,
things
sir.
are, but right now if you want to ask any question, let them be related to this potential energy and kinetic energy, so that everybody gets benefited. All right.
Yes, sir.
I mean, no. Now, for example, if you want to study any extra, you study for this potential energy, kinetic energy, mechanical energy. All that you study and then bring those doubts. For example, I'll be teaching you pressure also. Thrust and pressure is there. When I'm teaching that, you can bring all those questions. Is it clear, Vaishali?
Yes, sir.
So there are hundreds and thousands of things, no? Hundreds and thousands of things. So when we cannot study them at one time it's not possible. But as we are bringing the concepts, you can keep on asking them. Okay, Vaishali?
Yes, sir.
Okay. So I really like the mindset you have. You are getting into so many things and you are learning all those things. And this is what is needed. The curiosity is needed. Curiosity of finding out, curiosity of doing it, why I'm not getting, why, how it should be. All those things are very important. Okay, dear children, I'll be seeing you at 2 o'clock and I will be posting it in the group also. Have a good day and bye bye.
Thank you,
Thank you,
sir.
sir.
Bye.
Bye, sir. Have a
Yeah.
good day, sir.
Bye.
Thank you, sir.
Bye.
Bye, sir.
Bye.
Thank you, sir. Bye, sir.
Bye.
Bye, sir.
Bye, everyone. Bye.